Okay guys, question 2. So I won't read all this out, but essentially this is the predator-prey model. So there's mackerel, fish, and the sharks are eating the fish, and the more they eat, the more sharks there are, but the more sharks there are, the less fish there are, so the sharks start to die. You should be familiar with the predator-prey model. Anyway, this is the rate of change of the number of mackerel, and this is the rate of change of the number of sharks. So I'll just go straight to this bit here. The term alpha M, so this is alpha, beta, gamma, and delta. Alpha M models the population growth rate of the mackerel in the absence of sharks. The term beta MS models the death rate of the mackerel due to being eaten by the shark. Suggests similar interpretations for the following terms, right? So I'll just do it here, guys. This is the growth rate of the mackerel. Sorry, this is the growth rate of the mackerel, and then we subtract the death rate of the mackerel because they're being eaten. So the total rate of growth is this minus this. So this would be similarly this is the number of well, it's the birth. Let's say it's the birth rate. I don't like to use the word growth rate because this is the rate of growth. So it's the birth rate of sharks. And then this is the death rate of sharks because sharks are dying. Death rate of sharks. So the total growth rate of sharks, the rate at which the population is growing, is the birth rate minus the death rate. And that's it. Okay, part B. An equilibrium point is a set of values such that dmdt and dsdt equals 0. You should know that, guys. The equilibrium point is when the rate of change of the mackerel, population of mackerel and sharks is 0. So there's no change. It says show that at the equilibrium point the value of the mackerel population density is delta over gamma. Okay, so the delta over gamma is going to come from this equation, guys. So I can say that gamma ms minus delta s equals 0. Then I can factor out the s, so s, and I can say gamma minus delta, gamma m minus delta equals 0. So either this is 0 or this is 0. Now s isn't 0 because we know there are some sharks there, so s is not equal to 0. So gamma m minus delta has to equal 0, and I'm nearly there. I just need to say gamma m equals delta, adding the delta, and m is equal to delta over gamma. Okay, that is part I. Part I. Find the value of the shark population density at the equilibrium point. So this is basically the same thing, but we're going to find S. So I'm going to say alpha m minus beta ms equals 0, and we're going to find S. But same thing, m into alpha minus beta s. This is factorizing, equals 0. M is not equal to 0. Similar reasons. We know there's some mackerel there. So alpha minus beta s equals 0. Beta s equals alpha, and then s is equal to alpha over beta. Okay, that is parts A and B.